They told us the sky would be quiet tonight. Then the screen filled with a single impossible line, a shadow 100 times larger than the interstellar visitor 3I/Atlas, entering the survey frame as if it had been waiting outside our attention. It did not drift, it pointed. It locked onto the smaller traveler with a steadiness that looked like intention. The narrator, the one you hear now, works as an investigative journalist embedded with a public observatory. Our rule is simple: verify twice, dramatize never. We record the microphones that hum in dark control rooms, the shutters that click, the arguments whispered when numbers refuse to behave. We also record silence, because silence often means someone is deciding what must not be said. The timeline begins at civil twilight, when the all-sky camera in the desert caught an asymmetry in the nightly star wash. The pipeline flagged a transient with a reflectivity curve that rose too cleanly, like a mirror lifted to dawn. By nautical twilight, 6 observatories had the same brightening, each with different instruments, each seeing the same smooth ramp. The motion fit the interstellar comet's approach corridor, but the amplitude dwarfed it, like a stadium light next to a match. At first, the team treated it as coincidence, an ice-rich fragment on a near-parallel track, perhaps, tall geysers venting carbon monoxide and carbon dioxide, making its cross-section swell beyond reason. But the overlay told a colder story. The bright body was not merely near the path of 3I/Atlas. Its vector leaned toward it day by day, course-correcting in tiny ways that accumulated like a secret. Stop. Listen. This is the mid-hook. A thing bigger than our question is steering toward our question. If this is natural, why does it behave like navigation? Scale sharpens fear. The cross-section we inferred was not an abstract statistic, it was a moving wall. The energy needed to keep that wall so steady against solar pressure and outgassing would feed a city for years. If the interstellar visitor is a modest cathedral, the newcomer is a fortified valley, all angles and cool brightness. When the two are placed in the same frame, the smaller body looks like a pilgrim walking in the lee of a silent armored procession. Officials answered with practiced calm. The Planetary Defense Office issued a bulletin using the language of precaution without alarm, citing ongoing analysis and the wide range of uncertainties. A spokesperson reminded the press that non-gravitational accelerations can mimic intent, that comets breathe in unpredictable ways, and that detection pipelines sometimes smooth ragged truths into clean illusions. The message was careful, professional, and to many ears, too even. Outside the institutions, the citizen network lit up. Radio hobbyists sent logs of a rising hiss against the galactic background at frequencies where comets are not known to sing. Amateur photometrists posted light curves with small, repeating ripples, like a heartbeat behind a wall. A retired radar technician, using a home-built dish, wrote that the echo from the large object had edges, as if facets were turning to meet the signal. He was mocked by morning and taken seriously by nightfall. In the control room, our air was coffee, fan noise, and the quiet of people leaning closer. The act of watching becomes a kind of prayer when the stakes are unclear. Someone killed the overhead lights, and the only glow left was the square truth of the monitors. On the main display, the trajectory solution tightened with each unblinking minute. The newcomer's approach did not waver. The smaller traveler stayed on course, as if unaware, or as if trusting a schedule we had not been invited to read. Opposition shaped the hours. Caution against speculation, curiosity against caution, openness against order. The debate turned on a simple axis. Do we publish everything we see, raw and unfiltered, risking panic and misinterpretation, or do we protect a fragile public with phrased uncertainty and slow release? The history of the sky bears both virtues and both failures. We have been misled by mirages. We have also been saved by alarms that sounded early. Before midnight, we tested the alignment again, this time with an independent solver and a deliberately hostile set of assumptions. The match held. The large body bled light at a rate suggestive of panel planes rather than dust, and its polarization stayed high even as phase angle changed. If it is a natural shell, it is an exquisitely unnatural one. If it is a craft, it does not care that we are learning to name it. Outside, the town had stopped pretending not to look up. Porch lights went off one by one, as if the neighborhood had agreed to dim for data. Children pointed where their parents could not name. A distant train horn crossed the night like a measuring tape. Under that ordinary sound, the numbers performed their slow, ruthless work, refining, excluding, insisting that the larger body and the smaller were converging by design. Now, if this is not coincidence, what is it? Do not call it a motor, they said. Say non-gravitational acceleration, yet the curve refuses to behave. As in part 1, the path of 3I/Atlas drifts off the gravity-only solution in a way that looks chosen. If it is a motor, what is it aiming for? The narrator remains the embedded reporter in the public observatory. Our rule holds: verify twice, dramatize never. Tonight, the raw files arrive from survey telescopes, narrow field trackers, a rented radar dish, and a ring of university spectrographs. We strip interference. We cross-check timestamps down to the heartbeat of each shutter. The pattern survives the purge. Think of 3 kinds of acceleration. One points back toward the sun, the gentle shove of heat and vapor at local noon. One rides along the direction of motion, a persistent nudge that changes arrival times. One is sideways to the orbital plane, the term that tilts the story. In our fit, the sunward part is modest, the along-track part has teeth, and the cross-track part is not zero. Random venting would blur, not aim. We build a baseline outgassing model. Imagine jets of carbon monoxide and carbon dioxide bursting from fractures, turning ice into exhaust. Vary the flow rate and the nozzle angles relative to the spin axis, and you can write a decent part of the observed drift, but not all of it. To hit the fit, the jet directions must gimbal by a few degrees every few hours, and the spin must stay disciplined when torque should make it wander. Spin is the quiet witness. The light curve of 3I/Atlas carries a flicker that encodes a rotation period and a crude shape. Across a week, the period slides by seconds, not minutes, as vents open and fade. A natural geyser would slap harder and make the period bob and weave. Instead, the change looks like a hand on a dial. Precession is mild. The principal axis refuses to tumble. Heat agrees. Simple thermal models with rough, dark surfaces predict strong day-night asymmetry and a slow cool down after sunset. Our mid-infrared measurements show less asymmetry and a quicker fade. Either heat is moved out of view or the body radiates in a way that hides the usual glow. Spectra add another oddity. The carbon monoxide line is stronger than expected for this solar distance, while hydroxyl and dust lines are comparatively flat. 2 camps form, and they argue like family. The naturalists hold that fractured geometry can mimic purpose, that vents can open and close in seasonal rhythms, that shadowed caverns can act like nozzles. They cite comets that pulled similar tricks, if smaller. The interventionists reply that the acceleration vector is tidy, that the jet angles appear tuned, that noise never drowns the signal. The naturalists say extraordinary claims require extraordinary proof. The interventionists answer that the extra mid-hook. If there is navigation, who wrote the command? We ask the orbit dynamicist to translate the equations. She says, the path of 3I/Atlas fits when thrust points in a frame tied to the body, not to the sun. That is the tell. A thermal story wants the sun for a compass. This story wants the object itself for a compass. She does not say craft. She does not need to. Her caution lands heavier than any claim, leaving the room quieter and the screens strangely louder tonight. Then we call a propulsion engineer who does not believe in visitors and still does not. He runs numbers on a pad, with gas at cryogenic temperatures and a nozzle expansion that matches the observed brightness. He estimates a thrust small enough for a satellite if the mass were tiny, but 3I/Atlas is not tiny. Therefore, the specific impulse must be higher than a simple geyser can supply, or the duty cycle must be extreme, or there is a reservoir of reaction mass we have not yet seen. Against both camps we wage doubt. We try fits that let the spin axis wander. We add dust pressure with generous coefficients. We permit camouflaged fragments and charged grain effects in the solar wind. We even test a wild card in which our timestamps are wrong by a constant bias. Every time the best match returns to a directed tendency, not a shove, a bias that refuses to go away. Forecast beats motive for now. The meeting corridor that drew tight at the end of Part 1 tightens further under tonight's data. The window for closest approach between the larger, brighter intruder and the smaller interstellar traveler narrows from an evening to a handful of hours. Planetary defense officers repeat that Earth is not threatened, and they are correct, but the sky has neighborhoods. A close pass between two strangers matters even when our street is safe. We close with a question that does not need drama to bite. If a motor exists, its aim may be a rendezvous, a cover, or a test. The data cannot decide which. The numbers only insist that intention is plausible, closer to likely with each clear night. Our microphones record the ring of an empty mug, the clatter of keys, and the quiet breath we did not know we were holding. What exactly is 3I/Atlas being guided to do? They did not name it. The Citizen Network did, Swan. The first time we caught its signature, polarization spiked, and a razor-bright glint pulsed in step with 3I/Atlas. The glint was not noisy sparkle. It was a timed mirror sweeping through the phase angle like a metronome. In the control room, someone whispered that a fortress had stepped between a traveler and the wind. The word fortress stuck because nothing about the signature felt soft. Hard edges, disciplined rhythm, a kinship to intention, or the best imitation we have seen. We wrote it down, breath held. We inventory sources before we claim a thing. Polarimeters at 3 latitudes, phase curve photometry from small telescopes, time-tagged images from university mounts, a rented radar dish that barely reaches but sometimes hears differently, several spectrographs operated by graduate students who trust the sky but not one another's pipelines. We pour the pieces into a clean room of code and let them argue until disagreements shrink. After the purging, the pattern remains for now. The glint repeats, the polarization holds, and the cadence stays married to the smaller traveler. Now the geometry, specular reflection emerges when a surface is smooth at the scale of the wavelength and aligned to send daylight back to the observer. Our reconstructions of the bidirectional reflectance distribution function require at least a few flat facets arranged to present a mirror plane at repeating intervals. The phase angle dependence is too sharp for a fluffy coma. Simulated dust with aligned grains smears the spike into a gentle hump of ordinary brightness. Slow rotations blur it further. To match what we see, something planar must turn, lock, and return, like a lighthouse panel choosing its moments. The math points at plates, not clouds. In cold vacuum, radar is blunt here, the return is faint and the atmosphere shakes around the numbers. Still, a shape peeks through the noise. The echo rises and falls with a beat that matches a turning polyhedron, not a sphere with frost, not a cloud, something that turns like a box and gives a crisp rim when a face aligns. The instrument limits keep us humble, yet the way those edges climb in the same frames across nights gives the team a shared shiver. Illusions rarely keep such punctual appointments with us. Assuming Swan exists as structure, we test what kind. 3 candidates survive the first arguments. First, a Whipple-style cocoon, a sacrificial shell that intercepts micrometeoroids and plumes dust into a non-lethal cloud, thick enough to bruise any small projectile and thin enough to shed heat. Second, a directional shield made of panels that can cant and interpose themselves between 3I/Atlas and whatever hazard designers feared. Such planes would throw specular flashes when they yaw into sunlight, and their angles could march like drill. Third, a decoy array, a deliberate glare built to drag our instruments toward false centroids and false contrasts, masking quiet work in shadow. All 3 predict light that remembers geometry. All 3 could ride beside a fragile core. Each implies motive, protection, testing, deception. The sky has room for any of those stories. Each candidate makes a promise and a threat. A cocoon explains a radar cross-section and a quiet thermal tail because impacts churn without heating the shell evenly. A directional shield fits cadence because planes turn at repeatable angles that line up with our windows. A decoy insists on strategy. You build a trap when watchers need trapping. Predictions diverge where we can test them. A cocoon should shed bursts when micrometeoroids strike. The shield should correlate with acceleration teeth with specular timing. A decoy should bias astrometry and pull our centroid. We set these as predictions, not conclusions. We design nights that invite the sky to say no. Escort dynamics turn speculation into a map. Swan does not overlap 3I/Atlas. It holds a standoff, a few body lengths away in the brightest models, ahead by a small phase in others. When the small body experiences those strange tooth marks in acceleration, Swan is either leading or lagging by a consistent fraction of a rotation. That correlation does not prove causation, but it refuses coincidence. If you wanted to guard a delicate core, you would place a sentry that could lean into dust streams, throw glare at sensors, and shoulder minor debris. If you wanted to confuse observers, you would swing panels to tug our measurements. Either way, the choreography feels rehearsed. Practice leaves fingerprints everywhere. History is our caution. We once called Venus a swamp and traced canals across Mars. We waved away a narrow band burst and named it a curiosity, then argued ourselves hoarse for decades. Comets have fooled us with forward scattering that looked like engines. In a winter not so distant, a respected survey misread a ghost from its own software pipeline as a new class of thing. The sky repeats because we repeat. Every generation swears it will not be fooled. Every generation meets the trick it lacks practice for and pauses at the edge of the next guess. 1 foot on evidence, 1 foot on air. We tell ourselves caution is wisdom, yet curiosity keeps unlocking the door again. So the conservative case gets its day. Dust grains can align with magnetic fields, making polarized light where none was expected. Forward scattering can pile brightness into a cone and fake a mirror. Image processing can slice peaks and grow flats where there were none. Our polarimeters might be off by hair. Our radar might be tasting twinkles from satellites unflagged. The fix is not a speech, it is an experiment. We design tests that can break our favorite story without breaking the observers who love it. Mid-hook. What if Swan is not shielding 3I/Atlas at all? What if it is shielding us from a truer sight? Worse, what if 3I/Atlas is the lure and the fortress is the hand that points our gaze away from what matters? Whose hand and what debt would we owe for looking anyway tonight? Operational consequences arrive like a memo with ink damp. If Swan throws a sheet of glare, satellites will saturate. If it drags our centroid, orbit solutions will wander. If the shield can yaw, a plane could rotate to null-chosen radio bands and make deep dishes deaf at ours. The projected geometry of their meeting overlaps with patrol lanes that matter to governments than comets. Calls ask whether our observing schedule constitutes interference. Answers suggest a window when eyes should close. The order arrived at first light, short and clinical, stamped with urgency, but phrased in the soft grammar of caution. Effective immediately, optical and radio observations within a defined corridor of sky would pause. It read like a weather advisory and acted like a shutter. In the control room, monitors kept their glow, yet the room felt as if a glass dome had lowered over the night. The legal frame used familiar phrases: risk of interference, planetary safety, temporary protective measures. The language accused no one. It simply warned that harm might arise if eyes stayed open at the wrong hour. The order placed responsibility on observatories to comply, on satellite operators to geofence, and on data brokers to hold their pipelines. It soothed while it removed sight. Scope turned the abstract into a map. The corridor was narrow, and it crossed the region where the projected meeting of the large newcomer and 3I/Atlas would occur. Time windows were spelled out in careful blocks, with a primary blackout and a contingency overlap. Radio silence covered bands used by citizen dishes and guarded by professional arrays. Exemptions existed, narrow and heavily conditioned. The act of looking now required permission. Geofencing landed like a far switch. Commercial imaging satellites received task cancellations. Software that once returned clear frames now replied with a denial code, a polite refusal wrapped in milliseconds. Pointing plans on dashboards grayed out with a soft halo of not allowed. Downlink archives were marked maintenance, then placed under legal hold. The sky remained above us, but the machinery that turns looking into knowledge had stepped back from the window. The data freeze was subtler and colder. Public repositories posted banners about upgrades in routine service. Version histories stopped growing. Audit trails that once noted every edit and checksum fell quiet. Mirrors on university servers began returning a familiar apology and an unfamiliar duration. A few records even rolled backward, as if older snapshots had been restored because they were easier to bless. The effect was neat, professional, practiced. Leaks arrived anyway because leaks are older than orders. The documents were ragged, captured by phones and passed through too many hands. Yet through the blur we could read the outline of the missing story. Black bars cut paragraphs, but spare words survived. Collision avoidance test, protocol, SWAN, passive countermeasure rehearsal, re-radiation management. Each scrap tried to mean too much and not enough. We laid them on a table and resisted the urge to connect dots that might not belong. On camera, officials said what officials must say. There is no threat to Earth. The order is temporary and precautionary. Observing time will resume after the window. Off camera, a scientist who had argued for compliance said she feared the damage of a public guess more than the harm of a public gap. Across the room, an astronomer who had planned the next night's sequence asked whether silence had ever protected truth for long. The argument became human and stayed that way. Publish everything now and invite panic, said one. Publish nothing and invite panic later, said another. A third voice suggested a timed release with redactions and context. The historian reminded us that secrecy has rescued missions and also buried errors. The journalist checked the clock and thought about nights when testimony saved lives by arriving before the official statement. Ethics demanded a ledger. On one side, the public's right to see the sky. Open data that lets amateurs verify professionals. Trust built when peers argue over the same numbers. On the other, the chance that broadcasting trajectories and instrument settings during a delicate maneuver could degrade the thing being studied or interfere with it. The ledger would not balance. The hour insisted we choose a method, not a certainty. Countdown replaces debate when time grows short. The last legal observation slot became a choreography of restraint. We took the frames we were allowed, then shut shutters that do not like to sleep. We scheduled code to wake after the window, left notes that were more like wishes than plans, and exported backups across jurisdictions to stores that do not yield quickly. Citizens synchronized clocks and agreed on what the first minutes after the blackout should capture. Mid-hook. In that planned darkness, what exactly will pass between the fortress called Swan and the traveler called 3I/Atlas, and who benefits from our blindness tonight, this hour? Handing off is not surrender. We drafted a plan to rebuild the timeline using parallax from far stations, reopen satellite logs, and whatever scraps elude the hold. We templated affidavits from observers who saw with their eyes even when instruments were muzzled. We wrote questions that data must answer, so anger does not choose its own answers first. Then we looked at the sky, which looked back. The order remained in place. The corridor sharpened into the hour. Beyond our walls, plates might turn or not. Small thrusts might fire or not. Mirrors might sweep or not. None of us believed that nothing mattered during a blackout. Silence in one room is noise in another. We kept microphones running for the sound of silence. We stop here, on the lip of the window. The next frames, if they exist, will arrive without timestamps we can trust, or with timestamps blessed after the fact. The meeting that has fostered dread and wonder may be ceremony, rehearsal, triviality, or a chapter we did not expect to witness. We cannot answer yet. We can ask a better question. What in the dark are we being taught to miss? We returned to light and found noise where pictures should have lived. The blackout ended, yet the first frames after the window carried the hum of absence, timestamps rounded, gain curves flattened, star fields too clean. The control room breathed again, but the screens felt farther away. Outside, dawn waited. Inside, the story held a gap shaped like the hour we were not allowed to witness, an hour that ruled every sentence we could write. Inventory first. The meeting between the larger intruder and the smaller traveler, 3I/Atlas, now lies in 3 blocks, before, after, and a middle that reads like a redaction. Clock drift appeared at sites that never drift. Exposure stacks that should overlap now meet like strangers. Several sequences resumed with fresh calibration tags, as if a hand had countersigned instruments that do not usually ask permission to speak or pause for anyone's convenience. Accounts compete for the vacant hour. One team calls it a non-event. Another reports a minor accident, an ejection from the small body that briefly brightened the field. A third, speaking quietly, describes a ceremony. Timed orientations from the fortress, the network calls Swan, facing the traveler and facing away, as if rehearsing a liturgy of turning. All three stories fail the same way. None explains why the version history rolled backward and then forward, so we treat the missing hour as a crime scene. Audit trails expose troubling tidiness, smoothing functions applied twice, a rollback flag raised and lowered, checksums that match files no longer present. We find traces of late edits, not in pixels, but in the way the record tries to pretend it was never touched. That becomes our first usable clue. Someone cleaned the floor, which means someone believed the floor mattered more than the furniture. Now 3 scenarios the public can test. Scenario A, a peaceful environmental trial. The fortress positioned its planes to cast a controlled glare, while the traveler adjusted thrusts to hold inside a measured pressure field. The goal was to map how dust and radiation behave in a rehearsal corridor near the Sun, with parameters chosen to repeat later near Mars. Measure next. Polarization shifts that follow panel angles, micro variations in the traveler's light curve, and a thermal tail matching station keeping. Scenario B, a collision avoidance or deterrence drill. The fortress yawed, presenting a shield toward streams, while the traveler delivered sawtooth accelerations previously reported. The intent was to prove control under stress and to signal capacity to anything else moving along the corridor. Measure next. Correlations between specular flashes and non-gravitational acceleration spikes. Small asymmetric changes in trajectory that fade when Swan faces away, and transient dust wakes aligned with panel angles over time. Scenario C, a timed communication ritual. The fortress oriented panels to modulate reflected sunlight in a pattern, while the traveler answered with micro-thrusts that altered the timing of its brightness peaks. Imagine shutters opening and closing, a code from silence and glare. Measure next. Repeating intervals between glints that persist when geometry changes, subharmonics that return when the Sun, objects and Earth repeat angles, and notches in radio noise that align with optical rhythm. We will not wait for permission to test. The Citizen network now spans latitudes and longitudes to watch without a point of failure. We are releasing tools, an orbit fitter that respects parallax from backyard rigs, a polarization module that ingests data, a filter that detects smoothing fingerprints, and a chain of custody template for raw frames, hashes, witnesses, and timing. Mirrors of the archive live in jurisdictions where takedowns come slow, if they come. Governance must grow. We propose a compact, publish raw data with a delay measured in hours, not days. Allow narrow redaction only with logged reasons. Seat a council of reviewers who do not share employers, and let citizens audit together. When the sky gives a test that humbles us, secrecy should be the last instrument we pick up. Mid-hook. The next blackout will belong to someone. It does not have to belong to secrecy. Here is the call to action. Choose a station, synchronize clocks, store hashes offline, practice captures on bright targets until muscle becomes memory. Learn the cadence of fortress glints and the traveler's throb so the eye will catch a rhythm change. If your gear is modest, your continuity is gold. If your gear is rare, calibration is the spine others lean on. What did they come to do, and what will we choose to see?